Hi everyone. We're going to go ahead and get started here. Okay. Hi everyone. Robert Grant here. And we're going to go ahead and get started. So I can get this on. Okay. Well, how is everyone today? Good to see you. I had a busy morning already, but I had some pretty good news today. So I'm not in a bad mood at all, even though the news or the day was extraordinarily busy. But the good news I had was that looks like I'm going to get published in peer review here pretty soon on some of my papers with Talal, and very excited about that. You know, I'm now a member also of IEEE, which is the largest, I think, engineering organization around the world, and I've just a newly inducted member into the information theory side of things, which is actually number theory. So good to see you today. And we've got a lot to cover, so let's go ahead and get started. Well, as you can see here, and again, for those of you that are on Instagram, if you want to see the actual artwork, like very, very closely, for some reason, yesterday's session did not stay on the Instagram feed, but it was on Facebook. So we're going to go ahead and have Jamie. Jamie's my assistant. He does all my social media stuff along with me. I do about 75% on Instagram, and he does about 75% or so on Facebook. But we're going to have Jamie upload yesterday's presentation from Facebook onto the Instagram part of my feed as well, so everyone can see that really well. So with that, now you can see here I have, I'll go ahead and put this down a little bit so you guys can see this better. There we go. Now I bought this new iPhone holder, which is pretty cool, and I can't wait for it to come so I don't have to do this like microphone stand thing. And I bought a couple of them, so very excited about that. But before I get started today, I want to share with you another one of the cool tool things that I was actually gifted this by Nassim Haramain's team, as well as the team in one of our companies, which is called Thrivaltech. They're based up in Ashland, Oregon, and they're making a really, really kick-ass technology, which is meant to replace combustion engine catalytic converters. So you replace a catalytic converter or you augment the catalytic converter, and it turns a regular combustion engine into 0% emissions. And it uses plasma reformation in that technology. And I had led an investment in that some time ago, and the technology is just fantastic. It's basically met and passed all the EPA standards, and I think, you know, it's not everything is just going to go to electric. There's plenty of vehicles, motor vehicles that use combustion engines. So that team, though, was kind enough to gift me this set. Now, this set is pretty awesome. What this is this is golden ratio calipers. So you know, part of a geometry or not, right? So you could basically take this end to end, and then you would expect to see some line right here at the middle, which is exactly what's happening with this cube. So that's pretty cool. And you can do this on pretty much anything, and these are also a larger set, so I mean, you can go really big with this. So you can kind of do my hip bone connects to my thigh bone. Another simple caliper. It's full of blank pages. Well, not so blank for me, but you know, I'll just often use this as my notebook when I'm in the office and figuring out things like the discovery of n constant, which I just flipped to this page, which satisfies omega times Euler to the omega equals 1. And that has some significance on several different levels, but here's another one of my notes. So these black books work great for that. And I probably have about 50 to 75 of those kind of volumes. Okay, we're back on now. Sorry to the Instagram crowd, I don't know what happened. That was weird. We got knocked off, so my apologies on that. I just showed the Facebook crew these phi calipers, which are great. So you can kind of use it. Let's see if my arm is phi. Well, is it long enough? Yeah, actually, my arm is pretty much phi. Look, from here to the end of my biggest finger, my middle finger, is not exactly perfect phi because my hands are extraordinarily large. I've been told that by many people. So, so that's basically phi calipers. So I highly recommend getting a set of those. Those are pretty cool. What's really fascinating to me is when I do sculpture and I don't even think about using the phi calipers, and then at the end of the sculpture, I just by chance remember to measure it and to see what I get. And literally, I've never had a situation where it didn't turn out phi in the relationship, even though I hadn't measured it. So it's kind of bizarre that it happens that way. I don't know exactly how that worked and why I was able to get it to phi every time, but maybe it's just sheer luck. Who knows? Or maybe art is some form of channeling from the universe. Also, who knows? Bigger question on that. So you'll remember yesterday we had this particular geometry. Now, this geometry, I kind of halfway messed up on it, but you'll see I completely fixed it, and it's perfectly fine now. And I was able to do this in a way that is completely nested. So, and you do that through overlapping lines to make sure that, certain of your lines don't impinge upon other lines, and that allows you to be able to have this phenomenon where you can kind of have it really look like it's got multiple dimensions. Now, I'll just point out to you what are the different shapes that are embedded inside this. Now, you remember we started with a tetrahedron, which I have at center, and I put a little yellow in there because I always see yellow as kind of where life begins, right? And so green or yellow-green is the middle of the color spectrum. And from my days in the photonics industry, I've always been fascinated by yellow light lasers, and used in dermatology, they're used in what's something called photoselective thermolysis, which I think could be a principle that might be able to be used on treating the coronavirus. I've been thinking a lot about this over the last day or so since I realized that the geometry that I had discovered, the new perspective inside Metatron's cube for the hexapentacus truncated icosahedron, happens to be the exact structure of the COVID-19 virus. So I thought, wow, that's kind of amazing. So I thought maybe I should start thinking about if there's a way to use photoselective thermolysis to wipe out the COVID virus. But having said that, right, if you look inside this structure here, you're going to see a bunch of different forms. So we have a tetrahedron, which is the red triangle right at the center. Then I had a Merkaba, which I turned into a complete star tetrahedron. So it's coming out dimensionally. And the male aspect of this is the red, and the female aspect of this is the blue. Okay, now what I did is I mixed also to signify that male and female have to mate to create the yellow, the middle of the spectrum. So the male is red, therefore, and the blue is female, therefore. Those two mate together to create a yellow and yellow-green color. Now, that's why also I colored the lines inside of the male aspect blue to signify that the two had merged together. And then I was very careful to ensure that I didn't have any of this sticking outside of the larger brown cube that I put here. And the reason I chose brown was because the cube represents, of course, the Earth. It also represents time. And hypercubes in particular represent time. And so in one of our subsequent classes, I'm going to take you through time and how hypercubes work with time. And why the cube is the perfect form for that as well. And then what I did is I put a green octahedron inside of here. So you can see this green octahedron, again, signifying, the octahedron, I believe, is the exact shape of the Great Pyramid, except that it also has these small 1-degree indentations on each of the 4 sides, which makes it a molecule which would become silicon hydroxide in a solid form, but Si1 for silicone, H4 for silane in combination. So there'd be 4 hydrogens. So S1H4, and if you look up silane, which is the liquid form of quartz crystal, if you look up silane on YouTube, you'll find a video, I'll find several videos, in fact, of how that type of arrangement, that molecule actually creates combustible water. So it looks just like water, but as soon as it contacts the air, it catches on fire. I don't know what it tastes like. I've not asked anyone to taste it yet. But silane, I think, is something really important because it is the liquid form of quartz crystal. And as you know, quartz crystal is grown organically. Now, I'll give you an example of some quartz crystal. This is some of my quartz crystal that I have. These are arc crystals, in fact. I have a bundle of 8 right here. And these crystals are pretty cool. So they're grown, and they're made by this cool company called ARC, and it's part of Taurus Tech, and the Sim Hair Mine developed this technology. And it's a really interesting, cool device. It's kind of fun just to have these. And they're also magnetically charged so that they will stick together because they've got these titanium shelves that are magnetic. They can stick together in different structures. You can put them in the shape of DNA. I mean, some people have 64 of these. In fact, I think several people now have 64 of these. I only have these 8, plus I have probably another 4 or 5 or so that are individual. So I don't have enough to make the next cluster size. And this cluster type is called a gravitative cluster, the way this is set up. There's another version of it where these will be pointing outward, and it looks more like a Merkaba, and that's radiative. So we have here, and that, by the way, that structure is actually the structure of a cuboctahedron. So we have here now a brown hypercube that you can see here. Right, so that's pretty cool. And then we have another hyperoctahedron that I did in blue. And the reason I chose like a dark blue for the hyperoctahedron is because the octahedron represents air. And so when I ever think about air, I always tend to think about a blue sky for some reason. But interestingly, 78% or so of air is actually nitrogen. The thing with most oxygen in it is actually water, as we talked about on the water day, where we discussed the icosahedron. Now, the only structure that I haven't put in here yet is an icosahedron. So the icosahedron would be potentially on the outside of this. And then, of course, the last structure that I have drawn here, though, is, except for the larger Merkaba that we have, is we have this dodecahedron, which is now oriented in this direction. So it actually has a very unusual look to it. It's more in the north-pointed hexagonal shape, but if I did a north-pointed hexagon to actually frame this dodecahedron, which has 12 pentagons on it, then it would actually be askew on its side. So I like the way this looks because this is more rare. People don't necessarily do it this way as much. It's kind of a little bit extra work to have that orientation, but I think it looks really cool. So how's that look? So the mistake that I made yesterday, I've corrected. Isn't that easy? See, you can't even tell that I can't even find where I made the mistake, because what I did is I used the lines that I had actually made a small mistake on, because I was thinking about doing the hexapentakis on the outside, which we're likely going to try to do today. Then when I realized that wasn't the proper orientation for it, I was like, oh, that's right, I'm supposed to do a dodecahedron. So I just used those lines that I made the mistake on, which I think were right here, as the extra lines to be able to frame this dodecahedron so it can have this cool violet dodecahedron that really looks hyperdimensional. Okay, so are we ready to go to the next level? Okay, so let's go ahead and now plan to go to the next level. And I think what we're going to do here is let's start with an icosahedron. Okay, so because now basically this is kind of a review. Yesterday's class was a review to kind of incorporate all the different elements and all the different things that you have already learned how to do now. And so we have a nice example here of each of the different elements. And so using this overlapping approach to decide very deliberately where you want your green to show up and where you want your brown to show up and which things you want to be overlapping which other things, you can really determine how to make this look more and more real. And I think that's kind of the whole goal of this kind of geometry work is that you can take something that's purely two-dimensional on a flat sheet of white paper and turn it into something that looks truly three-dimensional. And largely what's doing that are these lines right here. These lines of Metatron is what's doing that. So I'll move this up here. So, and by the way, I've had lots of people ask, how can you turn off comments if you want to be able to see more of the screen? I have no freaking clue. So my apologies for that. Don't know how to do that. But I'm sure you probably have some friends or so that might know how to do that, and maybe ask them, because I'm not that guy. So with that, let's go ahead now and do our icosahedron. So remember how to do this. We're going to use this inner, right? This is like a mega geometry because we've got all the different platonic solids in it. We've even got some of the hyperdimensional solids in it as well. And let's, oh, and I just noticed that I forgot to put a couple lines down here, so I better finish this off. And of course, my pencils are now getting really short, so I'm going to have to somehow use some of my other pencils, which is fine. I can use my basic yellow pencils, which we all used in school. And all you have to do to kind of make it come out really good is just, if you only have number 2 pencils, just press down harder and press down more lightly. So it's kind of like a low-tech way of doing it, but it works just fine. Okay, so now we have our octachoron again, right? Which you can see this cube right here. I'll just trace it slowly. There's another hypercube, hypercubes right here. And by the way, you can make other hypercubes in different dimension by basically changing this line. If I wanted to, I could match it up against this line right here, draw a line right here, and what'll happen is it will overlap right here. So then I would take this line and I would draw it down to here, right, to create a different proportion of that hypercube. And it still works. So I could move this right here, and it goes right to here. And that's kind of like the breathing in and out also of this hypercube. And you can do that all on both sides. So there's many ways to approach the hypercube. In fact, the hypercube becomes truly the basis of all higher dimensional geometry in what's called tesseracts, right? Tesseracts are hypercubes. And you can have many of them arranged. Now, one of the things that people ask a lot about is something called the E8 lattice. There's a few people that have done quite a lot of research on this. Clee Irwin is one of them and his research team at Quantum Gravity. And what I noticed is that the E8 lattice actually follows almost exactly, in fact, the flower of life expansion. So as the E8 lattice has more and more layers that it goes out to, and greater seeming complexity, you can find all of that within the simple flower of life as you just go larger and larger and larger on a flower of life. You'll find that all the perimeter number of points on the E8 lattice is matching. I'll do a post on this on Instagram. It's matching the number of circles as you expand the flower of life further and further out. I always had a hard time with the E8 lattice because I'm like, wait a minute, if I have to see 8 dimensions, you know, we have a hard enough time seeing 5 dimensions, much less seeing 8 dimensions. And if I have to see 8 dimensions, if I could perceive 8 dimensions, I don't think I'd be sitting here. Let's not confuse dimensional points, right, with positional points. I think of dimensions as whole other octaves of dimensional awareness. When I think of the word dimension, it's kind of like we have an X and Y axis, and then we have a Z axis, then we have motion, that includes time. And the 5th dimension to me is implies motion, but it goes both directions. And that means that time should be able to flow in both directions. So with that, let's go ahead and start drawing our cool icosahedron. Uh-oh. You know what? I just realized I don't have any music. What's up with that? Hang on one second. I'll be right back. we go. All right, I'm back, everyone. Okie doke. All right, there. Need music for geometry. Thanks again to all the people that have been sending their pictures of the geometry. I'm totally blown away. You guys are awesome. And we've got some serious artists on this class. It's pretty amazing. I mean, people that are really, really good artists. They're probably more interested, or maybe interested in learning more of the geometrical, mathematical aspects of their artwork and how maybe to integrate some of this kind of geometric work more into their art. And but it's an honor to have all of you here. Okay, so now we've drawn the hexagon around this, and because it's already got these dimensional lines in it, it's like already popped off the page to me, right? So I can kind of see that immediately as like, okay, wow. And guess what? It's already formed. The beauty of this structure is that I can already see the icosahedron inside of here. Look, here it is. Here's the center triangle that's part of the octahedron. It's perfect that it's in blue. And then I've got the dimensional lines up here, right? Which comes to a point, right? And then the octahedron has another triangle here. Or sorry, the icosahedron has another triangle here, right, like that. And another one right here. So all the lines are already here. Then here's the bottom one, the two top ones. Isn't that cool? So now I'm just gonna go ahead and bold these out by putting this framing box around it, right? See how simple this is. It's like, this literally was already drawn for us. Of course, I can fix this little thing. One of the other things I do like to use is this little leather pad here. This is great because whenever I have stuff all over my eraser, this leather pad is, it's like, remember when you were in school and your eraser would get too much stuff on it and you'd have to like put it on your blue jeans and you'd have this weird eraser mark on your blue jeans? Well, now you can do it on this little leather pad and it cleans it off just like blue jeans do. Except blue jeans will also leave kind of a blue color, which you don't want, right? But that allows me now to clean this up. Okay. Okay. Like I said, I was pretty excited today. It was quite an honor to find out that they were, before they canceled the big number theory conference, it was supposed to be in Los Angeles, they were talking about asking me to be the keynote speaker, which I was like, wow, never thought I'd be doing that. That's for sure. At an academic society, that's pretty cool. Too bad everything got canceled with coronavirus, but I'm sure it'll just be delayed. We'll end up being on anyway, eventually. Right, some people basically say, wow, you're stretching us, trying to do so many geometries in one. Well, what's the old saying? No pain, no gain. Well, there's no pain here, but I think the way that we achieve greater things is by stretching our minds, challenging our brains. I think we're so much more capable of doing so many things that we have no clue what we could actually accomplish if we put our mind to it. And I think that's one of the great things about being a human being, is that we can challenge ourselves, and we have so much ability within us to do amazing things. And it's just a matter of unlocking that. And I believe that comes through balancing the mind. That as we merge the masculine and feminine and accept our own subconscious and true self-acceptance, then at the same time, two things happen. Number one, we start being really kind-hearted to everybody around us, and our life starts to really change. The people that are attracted into your life change, and yeah, sometimes you might lose some friends. You might end up with a very, very different career. I mean, I still have my previous career, but at the same time, I can't say that I am not involved in my previous career, but I am definitely involved in a lot of new stuff that I wasn't before. Just one second, I gotta talk to my gardener. Hi. The lumber's back there, behind the shed. To the shed. Sorry about that. I was not expecting that interruption. So, you know, your priorities definitely can change. That's for sure. What's important to you also can change. And the people in your life can change. And all of that can be very good. It all just comes down to perception. You know, I've never been happier in my life. I'll be looking forward to kind of going back to the office and doing regular day-to-day stuff and not being stuck in my house all the time. But I'm also grateful for the opportunity to do things like this. I mean, this wouldn't have even happened. I would have even never thought to do it. And what a blessing it's already been. Now, one thing to note also here is that as you get to larger and larger geometries, one of the things that's really important is to very much hold down your ruler. Otherwise, it can kind of get squirrely on you. So you got to push down really hard on it. Otherwise, you'll lose control of it, and you don't want to do that. You know what I'm going to do? I'm going to go ahead and fixing all these little bits and pieces here. Okay. And yeah, I'll go ahead and erase this one. This won't even get noticed when I've colored it, so you don't have to worry about it. Sometimes you make mistakes on the framing like this. It's not a big deal. You'll hide it when you color it, and that works just fine. Okie doke. So now we have our, well, we've got another side here to do. Let me see how I did this on the other side. Make sure I did this right. Okay. There we go. There we go. Okay, so now we have our pencil version of the icosahedron. And since it's already complex enough, I'm not going to do the back side of this geometry, but we certainly could. But it starts to get too many lines, and then you make more mistakes. I think geometry is kind of one of those games. It's like tennis in a way, where everything is about minimizing the unforced errors. Sometimes we rush and we try to do it too fast or whatever, and all of a sudden we make a mistake that we didn't need to make. Now, most of the time, mistakes are really easy to correct, so it's not a big deal. But every once in a while, you're getting out a new sheet of paper, and that's okay too. So last night I had somebody say something that was pretty interesting to me, where they basically said that they're like, oh, they can't believe that I was comparing light to sound. And that clearly I don't know that light is a different kind of wave versus sound waves, which are going to create standing waves. You know, every once in a while, you get people like that who are get really super disappointed or whatever because they're like, oh, I thought you understood this stuff better. No, I definitely do understand how the waves work. Transverse waves versus longitudinal, or compression waves. Sound is longitudinal and compression. But I think part of the reason why there's so much controversy over that particular topic is because the scientific community I don't believe they have the right understanding. They believe that there are these different forces in the universe, and that these different forces in the universe are actually, completely different than how I believe that they are, which is that because of the work of James Maxwell in 1860, as well as the work of several others, which include Walter Russell and John Keeley and others that had shown and posited that, and Tesla, that gravity is actually just an opposite condition of radiation. I think once people understand that, then it kind of changes the entire perspective on how the world actually works. And that then means that gravity must be an opposite condition of light, because if radiation is the opposite of gravity, then light is the output of radiation. It can be infrared or invisible light, whereas the output of gravity would then be the opposite of light. Now, most people still believe that light actually travels. I don't believe that light travels. It's kind of like, if I'm in a stadium in Japan, or rather, if I'm living in Japan and there's a big tsunami that hits, then that tsunami, by the time it comes to, across the Pacific, it hits Hawaii or gets to California eventually, the water molecules that arrive on the beaches of California are not the Japanese water molecules. The Japanese water molecules stayed in the same spot. What transferred was the wave itself, the wave propagation. So, for example, what I mean by that is that if you think about light as a photon, right? And you're also let's say you're in a big stadium and you do the wave, right? Everyone stands up, does the wave. Now the wave goes around the stadium, but do the spectators move? They just move up and down. They're not going around the stadium. And the same thing is true, I believe, and this is how Walter Russell describes it, and many, many others now as well, that there's an electromagnetic field, and that field has two conditions. One is excited, and the other is not excited. You could think of it almost like LED screen on a computer, where you have like some sort of game going across. I remember playing Atari, and there was this Pong game, and the ball would go back and forth on the screen. The photons aren't traveling. They're being excited in the LED screen, which has an excitation mode and a non-excitation mode, and the two are opposite conditions of each other. So this then speaks to this notion of potentially there being an ether, and this understanding, I think, is about to be proven. We see more and more in the physics world every day that's pointing to this notion that I think is just a higher understanding that we have been missing in the academic community for a long time. And this has been the subject of a lot of confusion in physics for a very long time. And I don't believe, you've probably seen my comments on this, I don't believe that there's more than one force in the universe. There's only one, and that one force is actually electricity. Male, female. So it's very simple. Now I've decided to go ahead and put, I don't know, I may live to regret this, but I'm going to go ahead and take the risk by putting in here, right, what would be the other pieces of this icosahedron in the background. Hopefully I won't regret it, because I noticed some of the pieces are already there, so I thought, why not? I'll just do it. Right. Okay. Now the hard part of doing this back stuff is just make sure you're not drawing too many lines that cover up the other lines. And then you got to make sure that when you do your coloring, that again, it's done with that in mind, that you know which lines you want to be overlapping and which ones you do not. And that's sometimes hard to remember. Okay, just like I tried to do there. All right. There we go. Here we go. It's a little bit trickier. There we go. Okay. There you go. So now I can color that in. You guys will be able to see how that looks. But now look, we've got all kinds of geometry sitting inside here. So I'll work on this and finish this up. And then I've got one more geometry that I'm going to put on the outside of this thing. And that's going to be, I think, a wrap on this one. So cool. Now, I'll go ahead and answer any questions you guys might have. Let's see. All right. Propagation of sector lines. Okay. Any questions anyone has? You know, one of the things that I want to go through with you guys is to actually show you how numbers themselves have geometry. Are you guys interested in that? Numbers themselves actually have a geometric shape and pattern. And I don't think this is well known by people, but let me go ahead and just show you this real quick. We'll end on this. All right, so we've got the number 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, have you noticed that there are certain numbers that look similar to other numbers on here? Let's see. So the numbers that look similar to other numbers would be 2, right, and 5. That's kind of interesting. So a 2 is like a backwards upside down 5. Okay. Now, everything has resonance. Everything has geometry associated with it. So I look at a logo, I think, does that have resonance? Is that something of note? Is it noteworthy? What other numbers have a similar characteristic? How about 4 and 7? Which is kind of like a backwards upside down 4 as well. That's interesting. So we've got 2 and 5 and 4 and 7. What else? What other numbers have this? And by the way, what is 1 over 2? Equals 0.5. It's like a mirror. And 1 over 5 equals 0.2. That's interesting. What about 1 over 4? Well, that doesn't equal 7. Well, maybe it does, because it's 0.25 and 2 plus 5 equals 7. And 1 over 7 creates this infinite number series, 1, 4, 2, 8, 5, 7, 1, 4, 2, 8, 5, 7, 1, 4. And if I add up all of these numbers in one period, this equals 27. That's interesting. Okay, well, the numbers that are all kind of second dimensional would be 1, which then splits like isotopes, 4 and 7. Interesting. Then the next layer, so you could say this is the first dimension. This is the second dimension. Because we're using just second dimensional shapes, straight lines, right? The third dimension has 2, so it's got 1 in it still. 1, 2, 4, 5, 7, and 8. So now we've got curves that have been introduced, but up against straight lines. So think of this as like straight lines of a grid, right? And you have a wave, like Maxwell's equations, right? I go like this. So this is basically giving us straight lines up against, right, other straight lines, right? The 2. 2. And then you've got an 8 which is the infinity symbol. What about fourth dimension? So you got 1, 2, 3, 4, 5, 6, 7, 8, 9. So we've now introduced 3, 6, 9. Now in our model, 1 equals gravity. 2 equals electricity. So it's positive charge. 7 equals negative charge, electricity. And notice 2 plus 7 equals 9. Then we have 5 equals magnetism, which emerges straight out of electricity and is just the opposite condition. So think of it as Maxwell's equations. You got your 2 and 5 sitting right inside here. Every time you double something, you're also having it somewhere else. And this is a negative charge, which then there's a positive form of magnetism, everything adding to 9. So the opposite of gravity, or vacuum you could call this, or even time, equals 8, which is the infinity symbol. It's light, photon. So now we've got electromagneto-gravito radiation, which then if I add these up, if I take gravity or vacuum and I add electricity to it, I get 3, which is an electron. If I take magnetism and I add it to the vacuum, it produces a positive charge of magnetism. If I take 4, which is the positive form of, if I take negative form or positive form of magnetism, I add 1 to it, which is the vacuum, I've now got negative form of magnetism. If I take 4, which is again the positive pole of magnetism, and I add it to electricity, it gives me a proton. Now, if I were to take an atom, I could make a double torus from this, and I've got a proton right here, which is centripetal force, inward force. Think of how we draw the number 6. And centrifugal force, think of how we draw the number 9. The number 9 is a neutron. The number 6 is a proton. And the 3 is the path of the electron around the double torus. Now, how many of you ever thought about numbers that way? That numbers actually have geometry encoded within them. Now, you might say, well, who created this number system? Maybe it's just inherent. Maybe it's inherent to consciousness itself. Even though there have been different forms of numbers, you'll find relationships across all of them. And this is very fascinating stuff. And in particle physics, we assign numbers to particles within physics. And this is the emerging field of information theory. So if you've got more questions about this, don't hesitate to ask. But actually, the 1 over x values are giving us these similar mirror reflections. And it's not just in number theory that we notice this. This then starts to transcend and go and find itself in geometry. And someone asked me, what would I call patterns? Patterns of consciousness. The definition of patterns of consciousness for me is geometry itself. So with that, great to see you all. I'm going to have to go ahead and end now, but hope everyone has a wonderful day, and I'll see you tomorrow. Bye, everyone. Great to see you all. And this will be up on Facebook. And thanks so much. Good to see you all. See you tomorrow.